All right, day 2, we are adding the last of our transformations. This one again, kind of showing you, I'll do this up on my board. Our parent function is in blue. We've got a negative outside of our function, that one is highlighted in red, and a negative on the inside of our function highlighted in green. And you can see when we have that negative on the outside of our function, it flipped our graph, our original blue graph, over the x-axis. And when we moved the negative to the inside of the function, it took our original graph in the blue, flipped it to the green, which would be flipping it over our y-axis. So summarizing that, what we're seeing is a negative that is inside of our function reflects our graph over the y-axis. We call that an ROY, or ROY. A negative on the outside of our function will reflect the graph over the x-axis, and we call that an ROX, or a ROX. Putting that onto our graphic organizer, this would be the very top one that says reflections. And in reflections, what we would probably note for ourselves is the symbol or thing that is happening in our function that causes a reflection would be a negative. And if that negative is located outside of our function, we get an ROX. The mathematical notation would be like this. And then what do I do to actually graph it? Well, we go to our table of favorite points. We take that negative, and we will actually change all of the signs on our y column. If that negative were to move to the inside of our function, we call it an ROY, or a ROY. The mathematical notation for that would be f of negative x. And if, again, I look at my table of favorite points, how do I actually do that? I would take that negative and I would go down my x column, and I would change the signs on all of my x's. So looking at some examples here, always start by just making your table of favorite points for your parent function. So this would be our absolute value of x. Our favorite points, negative 1, 0, 1, 1, 0, 1, when I plug them into my function. And this one, I see that we've got a negative sitting here, which would be outside of our function, which is an ROX, and an ROX changes our y column. So I go down my y column, I change the sign on every number, and then all I do is I regraph those points. So negative 1, 0, 0, 1, negative 1, and you can see that it took my graph, which normally would be a upside facing up V, and it flipped it over our x-axis. Moving that negative to the inside, I know it's the inside of my exponential function because of the parentheses. Again, look at your table of favorite points for an x cubed graph. I'm going to go ahead and extend this all the way from the negative 2 to 2, just so we can see it a little bit better here. Would normally be negative 8, negative 1, 0, 1, and 8. The negative is on the inside of our function here, which would be called an ROY. And ROYs change our x column. So I go down my x column and I change the sign on every number. And then we come over to our graph and we graph that. So positive 2, negative 8, positive 1, negative 1, 0, 0, negative 1, positive 1, and negative 2, positive 8. And we can see that now our graph is heading the opposite direction, got flipped over our y-axis. Our final transformation we're not going to look at as pictures because it's just really hard to see, and that is when we are multiplying by a number outside of our function. It affects our graph vertically by shrinking or stretching it. When we multiply by a number on the inside of our function, it affects our graph horizontally by shrinking or stretching it. And I put the word opposite there to remind us that everything inside is always opposite. So actually big numbers inside shrink our graph, and small numbers inside stretch our graph. So putting this onto our graphic organizer, again, this would be under the section that says shrink or stretch, and I would remind myself this comes from a multiplication. So if we are ever multiplying by a number, for it to be a vertical shrink or stretch, that number would multiply our function on the outside. How do I then attack a vertical shrink or stretch? Is that I take the number that is sitting outside of my function and I will multiply my y column. Everything outside of our function always impacts our y column. If that number that I just multiplied by is bigger than 1, it will stretch my function. If that number that I just multiplied by is a fraction, so something between 0 and 1, it will shrink my function. If I move that number to the inside of my function, it's like directly on the x inside of our function, it's going to horizontally impact our function, opposite of what we think it should. Anything inside our function impacts our x column. Now, opposite of multiplication is division, or multiplying by its reciprocal. So whatever that number is that's inside my function, I would turn it upside down. This is to note the reciprocal. And if the number that was inside my function happened to be bigger than 1, a big number, it will actually shrink my graph by the reciprocal of that. Example, if it had been a 3 in there, it would shrink my graph by 1/3. If the number that started inside our function was a fraction, something between 0 and 1, it would stretch my graph by, again, its reciprocal. So let's say the number that was inside of there had been a 1/5. It would stretch my graph by 5. When you are describing these, it will be a 3-word process. You must identify whether it is vertical or horizontal. So our first word when identifying would be vertical or horizontal. And again, that comes from, is it inside or outside? That's backwards. Inside is horizontal, outside is vertical. Our second word is it shrink or stretch? And then by, and then you're going to have a number that follows here, and that needs to be the number you multiplied your table of points by. Okay, and your words need to match. If you say shrink, you need to follow it with a fraction. If you say stretch, you need to follow it with a big number. So looking at, I've got 4 examples, one of each, inside and outside, so vertical and horizontal, and shrink and stretch, big numbers and small numbers. Looking at these side by side, we can see that no parentheses makes this an outside 2. With parentheses would make this an inside 2. And again, that will change it from being vertical to horizontal. This first one, outside, means that it is vertical, and vertical things are exactly what we see. We don't have to change anything. So since it's a number bigger than 1, we would say that's going to stretch our graph by 2. I take that number that's outside, I multiply my y column, and then I just regraph these points. -2, -16 is going to be way off my graph, like way down here. -1, -2, 0, 0, 1, 2, and then 2, 16 again runs way off my graph up there. But it would look something like that. Moving to the second one, inside of our graph means that I would identify it as being a horizontal transformation. It is a big number inside, so it's actually going to do the opposite and shrink my graph by its reciprocal, 1/2. And you can see that as I take that over to my x column, I multiply by 1/2, its reciprocal. Go down this column and multiply each of those numbers by 1/2. And just regraph those. So -1, -8, -1/2, -1, 0, 0, 1/2, 1, and 1, 8. And it took my original graph and squished it in half. Looking at those same outside and inside, but making them fractions now. Again, outside is always going to be vertical. Vertical, we don't have to change our thinking, so it is going to do exactly what we think. Small number is going to shrink, and we multiply by the number that's there. Vertical things impact our y column. Go down my y column and multiply everything by 1/2, and regraph those points. So -2, -4, -1, -1/2, 0, 0, 1/2, and 2, 4. And our last one, that 1/2 moves to the inside. Inside things are identified as horizontal. We think opposite. So a small number is going to stretch our graph by its reciprocal. And I take my inside number, turn it upside down, and multiply my x column. So multiply everything in my x column by 2. And regraph. -4, -8, -2, -1, 0, 0, 2, 1, and 4, 8. And it took our graph and stretched it twice as wide as it was before. We now have all of our different types of transformations. And so what we're going to start seeing is multiple different transformations show up in a function. So how do we attack that? Well, the order does matter, and the order matches our note sheet that has all of these listed on the back. The very first thing we do, before we ever even start attacking reflections, stress shrink, all of that, is just write out your favorite points. Okay, and then after you've written out your favorite points, the first thing you're going to scan through that function for is, are there any reflections? Are there any negatives? And I'm not talking subtractions, I'm talking negatives, like multiplying by -1. After we've found and addressed any of those, we would look for any multiplication, inside or outside, and we find and address those by multiplying the correct column in our table. And the last thing we would do is then go to our graph and count right, left, up, or down, and that would be any additions. My suggestions are on those first two steps is that you go to your table and you change your table. Once you've completed step 2, I would lightly, so at this point I would lightly graph your dots. And then I would go to step 3 and I would just count on the graph to move them anywhere that I need to move them, right, left, up, or down, and then put a dark dot where it will finally stop. All right, your assignment is the worksheet. I am going to look at number 9 with you, and the reason is anytime you have two things inside, it is a special case. And by the two things inside, I mean when we look at this function, the 2 and the -3. So anytime you have a horizontal shrink or stretch and a movement right or left, what you need to do is you need to factor out the horizontal shrink or stretch. So how do we do that in this problem? That would be taking that 2 out of our function. So if I go back and divide each of these by 2, I would get x minus, and then it's not very pretty, but 3/2. Okay, and then we start by looking at our table of points. This is an absolute value, so -1 to 1. Making sure to write down each of my transformations as I do them. It also asks us in this section to graph the original. Well, my original is those points I just wrote down. So I'm going to go ahead and draw that graph on here, a V centered at the origin. Okay. The first thing I would do is go to your list of things that we're supposed to look for. Do I have any negatives? And we do. We have a negative sitting out front. Outside is an ROX. And that impacts my Y column. So I'm going to go down my Y column. I'm going to make a list of all of our transformations here. After that, we would go to any multiplication. We have a multiplication on the inside. Inside things impact our X column. And I'm also going to use its reciprocal. Inside things we call horizontal. And because it's going to be multiplying by 1/2, I would say that it is going to shrink my graph by the number I multiply by. Go down that column, multiply everything by 1/2. Okay, and then at this point, I'm going to lightly dot out those points and then apply my last two transformations. So right now I've got a point at -1/2, -1, at 0, 0, and at 1/2, -1. And my last two transformations are inside subtraction. Inside subtraction would be moving right 3/2 or 1 1/2. And our last one is an addition outside, which would be moving our graph up 2. So I'm going to start with this point right here. I'm going to move it to the right 1 1/2 and up 2. Take the one at 0, 0 to the right 1 1/2, up 2. And take the one at 1/2, -1, move it to the right 1 1/2, up 2. And those final dots right there would be our graph.